Hola, amigos. So today is the last lesson in exponents and logs. Yesterday we talked about applications of exponential functions. Today we're going to deal with applications of logarithmic functions. So there's lots of different ones. We're going to do kind of the three main ones today. The three main ones are earthquakes and loudness of sound and pH scales. On a test or on a diploma, you may have one of these or you may have another one. And I guess the big thing I want to say there is whatever it's gonna be, don't worry about a formula. These would always be given to you. Usually they end up being given to you embedded inside the question. So it'll say, you know, the formula for this is this. Given this knowledge, answer this question. Okay, so they're usually right inside the questions for you, so don't stress about the formulas for these guys. So I'm going to give you a couple earthquake questions, a sound question, and a pH question, just to give you an idea of how we handle these. There's a couple different ways you can set them up. Remember, everything we do, we want to talk about communication. We want to make sure your communication is solid, and if you were to answer these on a written response question, that you're communicating in a good way how to arrive at the answer. You always got to think about that word determine, right? When it says determine something, it doesn't just mean the answer is of importance, it's the process on how you took to arrive at that answer. So watch your communication as we go through these things. So we're going to start with earthquake. The relative magnitude of an earthquake is given by the formula m equals log I over IO, where I is the earthquake intensity and IO is the reference intensity. Okay, so m is the magnitude, I is the intensity, and then this IO or I naught, sometimes you'll hear that called as well, is some sort of baseline reference intensity. We don't know what that is, and it doesn't matter, and you'll see why it doesn't matter in a minute. An earthquake in 1933 in Japan had a magnitude of 8.9. The 1976 earthquake in Guatemala had a magnitude of 7.5. How many times more intense was the earthquake in Japan than the one in Guatemala? Okay, so what we're going to do is we're going to start with what we're given. We're given this formula right here, this m equals log I over IO. So we're just going to start there. I know two different m's, which means I have two different equations right now. I have a magnitude for Japan, so I have an equation that involves Japan. I have a magnitude for Guatemala, so I have an equation for Guatemala. Now, what I want to think about is isolating for I here, okay? So I want this guy by himself, and over here I want this guy by himself. Well, you can see that I'm going to have to undo a log to do that. And to undo a log, the easiest way to do that is to switch to exponential form. So remember, base becomes the base. Dude that was by himself will now be locked into the exponent. Dude that was locked into the log would now be free. So that would look like this. 10 to the 8.9 equals I, the intensity of Japan here, over IO. And then if I want the intensity of Japan by itself, I just multiply both sides by IO, and I would get IO times 10 to the 8.9. Now, over yonder on the right side here, I'm going to do the exact same thing. I'm going to switch that to log form, and I end up with the intensity of Guatemala being represented by IO times 10 to the 7.5. Now, quick conversation we need to have here so that you understand where the rest of these conversations go. If I'm 60 and you're 20, I am blank times older than you. Well, you know the answer to that to be 3. But how do you know that mathematically? If you want to mathematically arrive at that 3, you're taking the larger number and you're dividing by the smaller number, and that's giving you this ratio of intensity. Okay, so in this quick example to talk about here, I'm saying that my age and your age are the intensities we're dealing with. So I would be the stronger intensity right now because I'm the older person. I'm the one who's 60. You would be the weaker intensity because you're the younger person. You're the one who's 20. Okay, so what we do when we're trying to find these ratios for intensity, we just take the big number or the stronger number or the larger number, however you want to look at that, and we divide it by the smaller number or the weaker number. okay? So if we take that thought and we go back to the earthquake, we end up with a ratio here to be the intensity of Japan was the larger number, so I put the larger number on top, and the intensity of Guatemala was the smaller number, so I put the smaller number on the bottom. Now you can see why it doesn't matter what that reference intensity is, because they divide each other out here, and I'm left with 10 to the 8.9 over 10 to the 7.5. Well, we know that when we're dividing powers of the same base, we just subtract the exponents. So that'll be 10 to the 8.9 minus 7.5, which ends up to be 10 to the 1.4, which ends up to be 25. So our conclusion here would be that Japan earthquake was 25 times more intense than the Guatemala earthquake. Okay, now, just as a quick conversation before we end this question, I know I said in the introduction, there are a few different ways you could set this up. The other way to have done it would have been a straight up system of equations and to try and solve it that way. So what you'd be actually doing there is you would isolate both equations for IO, because IO is the same in both equations. So if you had them both isolated as IO, you could set them equal to each other and then solve. In some respects, that's probably slightly more confusing than the way I did it here, but visually, what it would do for you is it would actually give you a statement that reads the intensity of Japan is 10 to the 1.4 or 25 times the intensity of Guatemala. So I guess the nice thing about doing it as a systems of equations is you keep your placeholders of the intensity of Japan and the intensity of Guatemala, okay? So that's another way you could try it if you wanted to do it that way. Okay, so now let's move to loudness of sound. Loudness of sound is measured in a unit called decibels, which is little d and big B. The B is capital there because it's Bell, which is somebody's last name, happens to be Alexander Graham Bell, inventor of the telephone, good Nova Scotian boy, and a famous scientist for lots of other reasons. The loudness or intensity of sound is given by this formula. So decibels is 10 times log of I over IO. First thing I want you to notice is this looks very similar to the earthquake intensity, okay? Or sorry, the earthquake formula. The difference here is that 10 in front. So we'll have to deal with that 10 when we go to isolate. So all of these questions, all of these logarithmic applications, they're gonna be handled roughly the same way, but all of their formulas just have small little tweaks to them with reference to whatever we're talking about. So this small little tweak from the earthquake one is that there's a 10 right there, okay? So normal conversation has a decibel level of approximately 60, whereas a power saw has a decibel level of approximately 110. By the way, you'll bust your eardrums at 150. That's why when you're using a power saw, you should have protective gear on your ears. How many times more intense is the sound of the power saw compared to the sound of normal conversation? So I'm gonna set things up the same way. I have two different decibels, one at 60 and one at 110. So I set up my two equations. Now I'm gonna try and get that ratio by itself so that I can write this in terms of the intensity. I need to divide by 10 on both sides first, and then I can switch it to exponential form. So I divide it by 10, I switch to exponential form, and then I get I to the n, or IN here, the intensity for normal conversation. I'm subscripting them, sorry, can't talk today. I'm subscripting them just so that we keep them separate from each other. So the intensity of normal conversation is represented by the reference intensity times 10 to the 6. Do the same thing over here, and I get the intensity of the power saw is the reference intensity times 10 to the 11. Now I'm ready to set up that ratio we were talking about. This guy here is the larger number, so I'll end up with this guy on top, divide it by this guy, and then that will give me the ratio. So my IOs will divide each other out. I'm left with 10 to the 11 over 10 to the 6, which is 10 to the 5, which is 100,000. Okay, so a power saw has a sound intensity that is 100,000 times more intense than normal conversation. Okay. Awesome. All right, now we're going to go to pH scales. Some of you may have worked with pH already from chem. I know it's worked with in chemistry. We want to take a look at it more from a mathematical standpoint as far as how to deal with the logs. So pH scale is used to measure the acidity or alkalinity of a solution. The pH of a solution is defined as pH equals negative log of hydronium. So in this case, it's the hydronium that's actually the intensity of the thing, okay? So don't get lost because there's not an I there. It works the exact same way, where H plus is the hydronium ion concentration in moles per liter. A neutral solution, such as pure water, has a pH of 7. Quick survey, does Calgary have pure water? The answer is no. We have slightly hard water, so we have slightly above 7. Okay, a liquid that, I know that by the way, because several years ago, we tried to have fish in my family and we killed them all, but that's a whole other story. Okay, a liquid that is very acidic has a relatively small pH value, and one that's very alkaline has a relatively large pH value. And if you've never worked with pH, I've given you some common ones here, just so that you kind of have a reference point. Okay, now, the question we're going to answer: how many times more acidic is vinegar, which has a pH of 2.8, than baking soda, which has a pH of 8.2? Again, same setup. We start with the equation and we want to try and isolate. In this one, we want to isolate for the hydronium. Okay, so before we can switch it to exponential function, we need to divide both sides by a negative. I apologize, that negative's in the wrong spot right now. That's just a copy and paste error that I'll fix before I PDF it, but that negative right now here should be over there. So we'll divide both sides by negative, and then we'll switch to exponential form. Okay, so switching to exponential form, the base is 10, so I end up with 10 to the negative 2.8, and over here I end up with 10 to the negative 8.2. Now, I'm ready right away to go to my ratio. Who is the larger number? Remember that these are negative right now, so 10 to the negative 2.8 is actually larger than 10 to the negative 8.2. If you have a knowledge of pH, the other way to look at that is a pH of 2.8 is more acidic, which means it's more intense than a pH of 8.2. Okay. So we set up our ratio. We have the stronger one divided by the weaker one. That's going to give me 10 to the 5.4, which is 251,188.6. And so vinegar is 251,189 times more acidic than baking soda. Okay. All right, one more question to go. Same sort of setup, just have to solve it slightly different because of the information I'm given. I actually had to look up how to pronounce this town because I decided if I'm actually doing a video, I need to say it right. This town is pronounced Riley. Riley. It's in Thailand, apparently. Anyway, an earthquake in Riley was measured to be 126 times as intense as an earthquake in Morocco. If the Morocco earthquake was a magnitude of 6.2, what was the magnitude of the Riley earthquake to the nearest 10th? Okay, so again, I just threw this formula back to you because you would never be responsible to memorize it. I set up the stuff I know, but this time what I don't know is I don't know this magnitude in Riley. So that's what I'm gonna have to solve. But the question still runs the same way. I want to try and get the intensity by itself, and then I wanna take the stronger intensity and divide by the weaker intensity. It's just this time, instead of finding the intensity ratio, I know the intensity ratio. The intensity ratio is 126. So that will allow me to figure out my missing piece, which is the magnitude of Riley. So I have the reference intensity times 10 to the 6.2 for the intensity of the Moroccan earthquake. And then I have the reference intensity times, I just called it R right now because I don't know what it is, to represent the intensity of the Rayleigh earthquake. It was the Rayleigh one who was stronger, so this guy's on top. So I end up with 126, because I know what the intensity ratio is, equals the big guy over the little guy. And now I'm going to go ahead and solve this. My reference intensities divide each other out. When I'm dividing powers that have the same base, I subtract the exponent. So this is going to end up being 10 to the r minus 6.2. And then I can solve that. I'm right back to a few lessons ago in solving exponential equations. This guy, I'm going to switch to log form. I can't make 126 be base 10, so I'll just switch it to log form. And that's going to give me log 126 is r minus 6.2, sorry. I'll add 6.2 to both sides and type that in my calculator. So I get 8.3. The earthquake in Rayleigh would have been a magnitude of 8.3. Okay, so what was that? Just 4 quick little questions to give you an idea of what applications of logs look like. Your task is here, and hopefully it goes well. But if you have any questions, feel free to get in touch with me. Have a great day, guys. Take care.